All right, welcome to the Explainer. Today we are doing a full tech teardown of the Google Pixel 10 Pro. We're going to see what really makes a modern AI phone tick. So how do you cram a supercomputer into something that fits in your pocket? Well, it's not about some single magic bullet. Nope, it's a symphony, a really carefully orchestrated performance between custom hardware and some brilliant software. So how'd Google do it? Let's dive in.
Okay, here's the plan. We're going to build this thing from the ground up. First, the foundation. Then we'll add the magic that makes it efficient. Then we'll install the brains of the operation. And finally, see what it all looks like in the real world.
All right, Section 1, AI in your pocket. Let's get right to the heart of this thing. The engine of all this on-device intelligence, Google's very own custom silicon, the Tensor G5.
So the Tensor G5, you gotta understand, this isn't just about making the phone faster in general. It's an engine built specifically for AI. It's got this thing called a Tensor Processing Unit, or TPU, and it's a beast. It's an accelerator designed just for AI math. This is what gives it the raw horsepower to run these really complex AI tasks right there on the phone. And that's absolutely crucial, right? It means it's fast and it means it's private because your data isn't being sent off to some server somewhere.
Okay, so we've got this super powerful engine. Awesome. But that power creates a whole new problem. A huge one, actually. These massive AI models, they eat up a ton of memory. So how does Google keep the phone from just, grinding to a halt? The whole secret is in how it manages its memory.
Whenever you're chatting with an AI, it has to remember what you've been talking about. It stores all that context in something called a KV cache. You can just think of it as the AI's short-term memory. But here's the catch. That cache just grows and grows and grows with every single thing you say. Pretty soon, it becomes the #1 memory hog on a device like your phone.
So to fix this memory problem, Google's engineers came up with this really clever algorithm called TurboQuant. It's a two-step process. First, something called PolarQuant kind of reorganizes the data. Imagine you've got this giant messy map. PolarQuant neatly folds it up, so it takes up way less space, but you can still find all the streets. Then a second step comes in and acts like a proofreader, using just a tiny bit of information to check for errors and make sure the map is still perfectly accurate.
And the result of all that clever math? A whopping 6x reduction. It shrinks that memory-hungry cache by a factor of 6. That is a total game changer. It lets you have much longer, much more complicated conversations with the AI, all happening right there on your phone. Okay, so we've got the powerful chip. We've got the super smart compression algorithm. But you still need something to connect all the pieces. A kind of high-speed bridge that lets the AI models talk to the hardware so everything works together perfectly.
And that bridge, that's LiteRT. It's Google's on-device AI framework. The best way to think about it is like the conductor of an orchestra. It's in charge of all the complex stuff, like managing that KV cache we were just talking about. But it also gives the software a direct line to the hardware, making sure the AI model, the GPU, and the neural processing unit are all playing in perfect harmony and at top speed.
All right, Section 3. We've got the foundation, we've got the plumbing all sorted out. Now it's time to install the brain. Now, the version of Gemini on the Pixel is super optimized for the device, but to really get a sense of what we're working with, let's see how its big brother, Gemini 3.1 Pro, stacks up against the other heavyweights out there.
Okay, just look at these numbers. This is where it gets really interesting. First, that context window. That's how much information the AI can think about at once. Gemini is sitting at 1 million tokens. That's 5 times bigger than its main competitors. Then, look at the price. $2 per million input tokens. That's just a tiny fraction of what the others cost.
But hey, it's not just about being bigger and cheaper. When it comes to the hard stuff, like complex abstract reasoning, look at this benchmark, ARC-EGI-2. Gemini is scoring over 77%. That is a commanding lead over both Claude and GPT. This shows it has some serious horsepower for tackling problems that require, actual intelligence.
And just to really hammer home that price difference, check this out. Let's say you have a big job for an AI. That workload would cost you a staggering $90,000 a month on Anthropic's Opus. On GPT 5.2, it's still 40 grand. But on Gemini, you're looking at maybe 14,000, and with a few simple tricks, you could get that down to just 3,500 bucks. That's not just a little cheaper. It puts powerful AI in a completely different league of accessibility. Okay, final section. We've got the custom chip, we've got the efficiency magic, and we have a world-class AI brain. So, what does this all actually do? Let's see how it all comes together in the real-world features on the Pixel 10 Pro running Android 16.
And this is where the rubber meets the road. You get features like Magic Queue, which can actually anticipate what you might need before you even think to ask for it. And things like that are only possible because that entire stack we've been talking about, the Tensor G5 chip, the TurboQuant memory magic, the Gemini model, it's all running right there, on your device. It's local, it's private, it's efficient. This makes it a true AI companion, not just a fancy terminal for a server in the cloud.
You know, this idea of vertical integration, designing everything from the silicon chip itself all the way up to the final features you use, that is what makes a modern AI phone what it is. Every single piece is built to work perfectly with the others, creating this incredibly seamless and powerful system.
So there you have it. We've basically built an AI phone from the silicon all the way up to the software. And what we found is this deeply, deeply integrated system. And I think the big takeaway here is this. The future of mobile AI, the race to build the best AI phone, it's not just about having the biggest brain in the cloud. No, it's about who can master this incredible, intricate dance between hardware, software, and AI, right in the palm of your hand. Thanks for watching.